Hey guys, I'm going to take a minute and go through some of the Tower of Power with you for lesson 33 in Zern. So this is the end of topic lesson that really consolidates all of your learning. So I wanted to go over it with you guys on what that looks like so you can get a better understanding of what it means to be successful in this lesson. So we're breaking down to subtract. Our problem here is that we want to solve 1 6/7 plus 1 4/7 by adding like units. So what that means is, where are these similar? In this particular case, we have 1 whole plus 1 whole. Those units are like. They both represent whole numbers. So I'm going to go ahead and enter in my 2. Now I also notice that my fractions are like units as well. What makes them like units, what makes them similar, is that they have the same amount of pieces to create a whole. They are both sevenths. So now I add my sevenths together. So I have 6 sevenths plus 4 sevenths. When I add those together, I get 10 sevenths. Okay? So now I take that whole and that fraction, and I could add those together to get 2 and 10 sevenths. Now, the issue with that is 10 sevenths is an improper fraction. We know that when we think of the whole, that 7 on the bottom lets us know it takes 7 parts to make a whole. Meaning we have already surpassed that whole. We have more than 1. We can break that apart into 1 whole and 3 sevenths, or 7 sevenths and 3 sevenths. That's going to go ahead and alter our answer a little bit. So now we're not thinking about 2 and 10 sevenths anymore. We're thinking about 2 plus 7 sevenths plus 3 sevenths. 2 plus 7 sevenths is 3, and we have no sevenths to add on. So now we get 3 and 3 sevenths. So we're going to keep climbing this Tower of Power here. And we're going to connect that strategy that we use for addition to subtraction as well. It's going to look a little bit different, but we also need to remember the relationship between these two. They're inverse, they're opposite. So we can flip this problem and change our mindset to an addition standpoint to also come to an answer. So that's why our question here is asking, write the subtraction sentence as a related addition sentence. So I have 3 2/5 minus 1 4/5 equals question mark. That's my unknown variable. So I can think about doing, well, if I add 1 4/5 to whatever that potential answer would be, I would end my result with that 3 2/5. Remember, the difference is the answer to a subtraction problem. It's kind of the space in between your difference, the answer, and that original number you're taking away from. So I'm flipping that problem to make it work for me so I can continue using that strategy. This is where our number line comes into play. I'm going to start at that 1 4/5, and I'm going to use this visual to assist me in figuring out, well, how many jumps do I need to make to get to that 3 2/5 that I started with? When we think of subtraction, right? We start with that and we work our way down to subtract, but we know that sometimes subtraction can be a little bit more challenging. So that's why we can flip this problem and think of it from an additive standpoint and continue to add on. So if we take a look at this number 9, we notice that the first step we're going to take is adding on to get to the whole so that we can continuously jump from whole number to whole number. So I'm starting with that 1 4/5. If I jump 1/5, I know that that's going to get me to 2. So I'm going to go ahead and document that jump to 1/5 to get me to that 2. Now, I am not at my answer yet. I need to get to 3 2/5. And my goal is to figure out how many jumps it's going to take to get there. So my next step is to think of the whole. Well, the jump from that 2 I am now at to 3 is 1 whole. So far in this work, I figured out, okay, well, if I start at 1 4/5, I at least have to jump 1 1/5 on my way to 3 2/5. I'm not there yet. I still have one more jump to make. From that 3, I'm going to go ahead and jump to get me to 3 2/5. I am not jumping 2/5 because that would not, well, hold on, let me rephrase that. I am not jumping 2/5 just because that's what it says there. I'm jumping to get to 2/5. Okay? So if we look at these two different options, well, I'm trying to get from 3 to 3 2/5. So this would be 3 1/5, 3 2/5. This option here would not be accurate. You have to remember the numbers on the bottom. So sure, you're 2 away from the whole, but you didn't jump 2/5. Now, in this case, when we jump that amount, because we're at the whole, that's how much you have to add on. Be careful and slow yourself down on this step to make sure that you're doing it correctly. So now I can add all of these hops that I've made together because I found the space between the two. I found the difference between 3 2/5 and 1 4/5. I have one whole, and together I have 2/5 plus one more fifth to get me 3/5. So my solution, my difference is 1 3/5. So if we think back to that strategy we used with addition, with combining those like terms and adding them together, we can utilize that in this strategy as well. So we're going to first subtract the wholes. So the problem here is to solve 4 1/5 minus 2 4/5. I'm looking at my wholes and I'm recognizing I can do that subtraction quickly and move myself along in this problem. 4 minus 2 is 2. That now becomes part of that 4 1/5. I took away 2 wholes from that 4 wholes. So now I have 2 1/5 minus 4/5. Now I'm looking at that problem and I'm thinking, okay, well, I have to subtract my fractions here. If I do 1/5 minus 4/5, it's not necessarily something I can do very easily. So now I need to think, what's a strategy I can use to subtract here? What's a quick way to come to the solution here? So what we're going to do now is break 4/5 into 1/5 and 3/5. The reason we're going to do that is we have to be able to take away from this 1/5. We cannot take 1 away from 4. But by breaking apart this 4/5, I have 1 that I can now take away from a 1. I still am representing that 4/5, but now I'm kind of doing 2 1/5 minus 1/5 minus 3/5. So by taking 2 1/5 minus 1/5, all I have left is the 2. Now we can't forget that that 1/5 came from breaking apart 4/5. We still have this 3/5 that we have to subtract. So now I have 2 wholes take away 3/5. So in my mind, I'm thinking, okay, well, if I start with a 2 on my number line, I'm visualizing it, and I go back 3/5. Okay, well, that's 1 4/5. That's one jump. 1 3/5. That's another jump. Then my third jump would be 1 2/5. So even if you don't have it in front of you, you can still visualize that number line and think about how you move your numbers along that line. So now Zern is releasing you to kind of think of this again. 9 1/5 minus 6 4/5. So in my mind, on my paper, I'm thinking, okay, 9, and I'm going to take away 6. When I do 9 take away 6, I end up with a product of what? Take a minute and think. 3, yes. So now I have 9 minus 6, and I have 3, and I'm going to go ahead and add 1/5. Because it's 9 1/5, take away that 6. So now I have 3 1/5. I've already taken away that 6. So now I have 3 1/5 minus 4/5. And I realize that might be kind of hard to see. Once again, I'm thinking, well, I cannot do 1/5 take away 4/5. But what I can do is break that 4/5 into 1/5 and 3/5. That makes my new problem 3 1/5 minus 1/5 minus 3/5. when I start subtracting across that problem, well, now I have 3 1/5 minus 3/5, or 3 1/5 minus 1/5. Well, that gets me 3. So now the new problem I'm working with is 3 minus 3/5. Once again, I count backwards. Well, on my number line in my head, I'm thinking if I make 3 jumps backwards from 3, that'd be 3 4/5, or I'm sorry, 2 4/5, 2 3/5, 2 2/5. So just because this strategy is something that we're talking about right now doesn't mean you can't use other methods to complete this work. You notice that last one, it said solve on paper and give me the answer. If you want to use that strategy and combine those like terms, awesome. If you want to use the structure of the number line that we utilize more towards the beginning, that's also something you can do. The goal in the end is for you to be able to add and subtract fractions. The steps you take to get there are whatever steps you need to take to get there. Once again, at the end, you had the option to do what you needed to do to solve. So remember all the strategies we've been using before and think about how you can apply those to how you learn right now.